All right, thanks everybody for joining. This is session 1 of the ClearBlade seminar series. This is a series of 30-minute sessions we're putting together, the aim of which is to enable developers who wish to build IoT solutions using the ClearBlade platform. We have a lot to do, so we're going to jump straight into our agenda. I'll start off by introducing myself and my company. We'll talk about the project we're going to build. Then we're going to go through a guided development where I will do the building and you will follow me. The pace is going to be brisk so that we can complete within the 30 minutes allotted, but I will try to go at a pace that you can actually follow me. Now, I want to make sure that in the chat, I have pasted the code that we are going to build. So worst case, if you are not able to keep up with what I'm building, there is the completed code in the chat that I just pasted, so you can go to that. And I'll try to leave at least a few minutes at the end for questions and answers. My name is Akash Sharma. I'm an IoT solutions engineer working at ClearBlade. And ClearBlade is a company that's focused on enabling our customers that wish to build IoT solutions. If you want to know all the details of what is IoT, I encourage you to look for seminars by our CTO, Aaron Alsbrook. He does a great job of laying out all the different technologies and standards that come together to make the IoT world and how we fit into that overall world. But I'll just say for now that IoT, which stands for Internet of Things, encompasses the goal of connecting things to the internet that traditionally don't connect to the internet. Traditionally, we connect computers of different kinds to the internet. But when you want to connect things like storage tanks, rail cars, refrigerators, water heaters, maybe barbecue grills, those are things that don't traditionally connect to the internet. But if your business depends on those things being connected to the internet so you can monitor them and control them, then you need an IoT solution. And I believe we have the platform that makes it easiest to build such a solution. You can either build your solution using components that we provide, and you're going to see those components today, at least some of them, or you can use some pre-built systems that we provide out of the box that already use those components. One of them is this one called Asset Monitor, which makes it very easy for you to monitor assets that are important to your business so that those assets are publishing information to the cloud, like attributes like location, temperature, vibration, things like that, so that you can monitor those and then you can execute rules based on whether those attributes go beyond certain thresholds, for example. This out-of-the-box system is one that we're on a repeated basis sharing with our customers and potential customers. So I encourage you to look for demos of that. But if you look behind the scenes of this very full-featured system, you will see components like what we're going to see today. Today, we're going to build a very simple system that does something very specific. It acquires one temperature, and it displays that one temperature. To do this, it will use one piece of code. Essentially, I've pasted the solution to that in the chat. It will use one portal or user interface, and it will use one user interface element or widget. We'll put all that together. We'll get a completed solution. It'll work end to end. And this temperature that we're going to monitor, at first I thought we could simulate it as a random number we generate. But I thought it would be more interesting if we used an actual temperature that is being published by a trusted source, namely the National Weather Service. The National Weather Service is daily publishing hourly forecasts in different regions of the United States. And I thought we could just look at one of these forecasts, pick a temperature, and use that as our temperature. So with that said, let's jump straight into looking at that API. So if you were to Google National Weather Service API, you would see a website that I'm going to share with you right now. You would see this website. And if you go to this website and you go to the specification tab, what you will see is several HTTP endpoints. that will return information that's useful regarding weather. Now, if you're not familiar with the terms HTTP and endpoint, for now, just think of each endpoint as being like an entity on the web that you can send requests to, and it will return some response. And these requests and responses are sent over HTTP, the same protocol that your web browser uses. So it's something very standard. The specific endpoint we're going to use today is this GridPoint Office XY endpoint. And if you wanted to try it out, you can actually do it right here. I'm going to ask a particular office for forecast information from a particular XY coordinate. These XY coordinates sort of correspond to longitude and latitude, but it's an equivalent grid across the United States. And this Weather Service Office, LWX, that's the code for the Washington, Baltimore office, which I believe is where the National Weather Service is headquartered. So if I hit execute, and if I wait, I will see in the response here a lot of information come back. Not just a temperature, but a whole lot of information formatted as a JSON object. Again, if you're not familiar with the term JSON, just think of it as structured data. Now, buried in this set of data, there is a properties item, and buried inside the properties item is a temperature item. And the temperature item is an array of actual temperatures, all in degrees centigrade. And you'll see that at a certain hour, the forecasted temperature was 25 Celsius. At a different hour, it was 25.6 Celsius, and so on. We're just going to use one of these temperatures as our placeholder temperature. The idea is in the future, those temperatures might come from actual assets, actual sensors, and this is just going to temporarily keep the place of that. So we'll probably pull out this second one right here, which is index number 1. All right. So let's start building, and I would like you guys to follow me on this as closely as you can. And I have muted everyone for the moment, so if you have questions, raise your hand or keep the questions until the end, and I will unmute everybody and we'll answer the questions at the end. I would like everyone to go to platform.clearblade.com with your browser. Chrome, if you can, otherwise, you know, Firefox or Microsoft Edge, anything you'd like, and log in. I hope everyone had a chance to create username and password, log in, and when you do, you should come to a page that looks something like this. Now, if you've already been here and you have created systems because you were experimenting, that's absolutely fine. That's what this is for. But you probably did not have a chance, and then you see what I see. So we're going to create a system. I'd like you to click on Add System right here and wait. So what is a system? A system is a grouping of components that need to work together so that your IoT solution is provided. Your IoT problem is solved. You'll see some of these components as we go along, but I'll tell you that you can start from scratch and build a system, or you can start from something pre-built. You can start with templates that we publish. Back behind the scenes, you see some templates that come from our IPM website, which I will mention again later. You could pull templates from GitHub. If someone has published a system to GitHub, you can pull that and use that as your starting point. Or you may have exported a system as a zip file before, and you want to now import it. You can do that as well. But for now, just choose empty and call this your temperature monitor. And the naming convention I recommend is camel case. And if you don't get this name right, it's not a big deal. You can actually change it later, but I'd like you to click create. Now, when you do that, you see the components that I keep referring to that are going to work together to make your system work. We'll see some of these today. Code, these are pieces of code, programs you write that do the actual work. Timers are entities that make things happen on a schedule or that synchronize the execution of certain events. Shared caches, these are how we store pieces of data in memory such that one piece of code might write the data, another piece of code might read the data, and it's essentially memory. Collections are like tables in a database that they're essentially contained in tables in a database that we host within our platform. And then you can even use external databases as part of as a component within your system, and so on. There's only two that we care about today: code and portals. So what I'd like you to do is to click on code, and we're going to add a piece of code. I want you to click on add code. And when you do, you see that you have 4 types of code that you can add. Let me quickly mention what these are. A microservice is a program that is invoked externally. So something calls it, it comes into being, it does something, provides a response, and then it goes away. That's the important thing about a microservice. It doesn't stay alive. It comes into being, does something, and then goes away. A stream service is a program that stays alive and waits for messages to be sent to it. When it receives a message, it does something and then waits for the next message. So it's pretty efficient because most of the time it's waiting. When a message comes in, it does something, but it stays alive. Configuration is a piece of code that contains some data that by itself doesn't do anything, but it can be used by other pieces of code. A library is a piece of code that contains functions, again, that cannot be invoked by themselves, but they can be used by other pieces of code, other services, or libraries. I want you to create a microservice, and we're going to call this get temperature. And this time I want you to be careful that you do type this in correctly. If you don't, if you want to change the name later, you do have to recreate the service. There's good reasons for that, but it should be okay. So go ahead and type that in and create. Now what you see next is something very important in the ClearBlade approach to IoT systems. We believe in security by default. What that means is all these components, by default, their use is disallowed to any entity that tries to connect to it. We explicitly authorize use of those components by saying, hey, for example, this collection, if you want to read it, you need to be of role authenticated. And if you want to write it, you need to be of role, for example, administrator. Then the entities that connect, and by entities we mean users and devices, they need to explicitly have those roles to be able to do those actions on the different components. Depending on what the component is, the action may be different. For collections, it might be read and write. For topics, it might be publish and describe, publish and subscribe. If you're not familiar with topics, don't worry, it's something we'll come to in a future session. We have 3 roles out of the box. For now, I'd like you to pick anonymous run. Now, this is not what you do in your actual systems. You would want someone to maybe not to be able to run a piece of code if they connect anonymously. But right now, we're going to do this because otherwise, you're going to see we'll need to create a user to be able to do the next part, which is build a portal. And I don't want to take the time to do that. So choose anonymous run and click add permissions. Now, the next thing we are asked to do is what libraries does this piece of code use? There's a log library that we add by default. That's okay, you can leave that there, but what's very important is I want you to pick this HTTP library. This is how we send an HTTP request to that endpoint using this library. Click that. You've got 2 libraries as dependencies. Click done, and you'll see at the top right of your code service, you've got these dependencies. Now, before we do anything else, I'm going to add a semicolon here. You don't have to, but just have it, I guess. I'd like you to click save and test. Don't do any coding, just hit save and test right here, and you'll see a dialog box pop up that says success. So what happened? We invoked this code service, and we passed it 2 parameters, a request and a response. The code used the request to see if there might be some parameters it needed. We didn't pass in any parameters. We could have by editing test params here. And the code service invoked a method of the response object called success. And think of that as just sending a signal back to the caller saying everything went well, and here's a message that shows that. Now, that being said, now we want this code service to do some actual work. So we're going to create our first object that we're going to use. I should mention at this point that this code that runs within our backend console, so to speak, is written in JavaScript ES5. Why JavaScript? It is the most popular language in the world, and we chose it as the one that would enable the most developers. And ES5, because we have an engine that we're using that can execute ES5 in the most performant way we have found. And so that's the reason for those design decisions. I want you to create your first object, request object, and it is going to be created by calling essentially what I call a constructor that's part of the HTTP library. So this is going to send that request to the endpoint. Now, when we call the function or the method that sends the request, it's going to look like this. It's going to be request object dot get, because that endpoint was a one where you execute a get rest method. If you're not familiar with those terms, just again, think of it as a request saying, hey, get me something. That's all it is. We're going to pass two parameters. The first one is going to be some options, and the second one is going to be a callback. Now, if you're new to JavaScript, the options is just like in most languages, you pass some data that's a parameter. But the callback may be a little bit different from what you're used to. A callback is a function you pass to this function. And you're basically saying, when you're done, please execute this function that I'm going to pass to you. Now, I hopefully gave you the function and the options. And what I'm going to ask you to do is, if you go to your chat, you will see both those pieces. The options, rec options, and the callback are provided in the chat. And if anybody is not seeing those, please raise your hand. Okay, let me explain a little bit what the options and the callback are. So the options, it's basically a JSON object with one item, this uniform resource identifier, which is the endpoint that we just sent a request to through the National Weather Service website. And the callback is a function that the get method will call by passing in two parameters, an error parameter and data. If there is an error, we basically exit this code service and send a signal to the caller saying something went wrong, and we send a message of what went wrong by taking the error data and building a string out of it. And if there was no error and things went right, we take the data, which is basically that large JSON object we just saw in the other website, and we pull out the properties item. From that, we pull out the temperature item. From that, we pull out the values, element number 1, which is the second one. And then we pull out the value item from there, and we send the response with that data. When you do all that, you don't even need this last resp.success, because by here, we would have exited. So with that, I'd like you to click save and test one more time. And what you should see is that temperature pops up. So far, so good. I hope we got 10 minutes to build the front end. To build the front end, I want you to click on portals. And I want you to add a portal. A portal, once again, is a user interface. And you can create it from an existing one. You can clone an existing portal, or we have a template for something very specific that we're not going to use today. We just want a custom portal, and I'd like you to call it temperature monitor portal, just like that. Don't worry about a description right now. Click create. And again, the authorizations are very important, but for now, I want you to allow an anonymous user to be able to do anything with this portal. Normally, you would have users that have certain roles be able to read a portal, and users with other roles to be able to read and write a portal. But for now, we'll just let anonymous do all of that, and I'd like you to click add permissions. Now you have your portal. I want you to click on this link. And what that does is it now takes us away from our back-end console where we wrote the components that are running behind the scenes. And this is what I think of as our front-end console where we create our user interface. We'll jump straight into it. I'd like you to click on this drop down. And if you scroll down, you will see there is a widget you can add called Speedometer. And I want you to just click on that and it gets added to your portal. Now you could resize it here, but it does involve changing like what the resolution of the screen is going to be. So we're not going to do any of that. We're just going to leave that widget, and notice that the value of the widget is right now 90. So we're going to see why that is. That value comes from a piece of code that ran in the front end, and it is a parser. So widgets have pieces of code that populate their data, and we call those data parsers. And they may have pieces of code that execute when an event occurs, like a button click if the widget has a button. And those pieces of code are called event parsers. This one doesn't have an event parser because we don't have anything we can click or drag or anything of that nature. We have a data parser. I want you to expand data parsers, and I want you to notice this code. I want you to click edit. And this is the code that ran that gave that value. It's different a little bit from what we write in the backend console in that it can be JavaScript ES6. It's still JavaScript, but it can be ES6. If you change this to some other value and hit apply control, you'll see the value of the widget changes. In fact, you could get rid of this entire JSON object and just put in some value there and hit apply control, and you see that the widget changes. Now, obviously, this is a simulated value. You want this to come from some real place. To do that, I want you to click on home up here. And then we're going to add a data source. So you see data sources, and I want you to click on plus to add a new data source. Where is the data for this widget coming from? Well, it's coming from that code that we just built. So I want you to pick code service. And since we only have one, everything gets populated for you. This code service will get called and will populate that widget. And you could have an interval that says every 5 seconds, execute this and update my widget. Please don't do that. Leave it at 0. The reason is I don't want this code to be running while we're not using it. And eventually we're not going to really, we're going to modify it anyway. So click apply. And then go back to your widget, mouse over your widget, and notice that there's a wrench icon. Click that. Now you're back to where you can choose a data parser. Click on the data parsers. Click on this calculated dialog box. Calculated just means it's not starting from a data source. You're going to change that such that it starts from a data source. Get temperature. Notice that something is not quite right. Edit. And right here where it says return CTX, which is context data source, change that to dot results at the end. Add a dot results, apply, and there we have it. Make sure you save your portal with this red floppy icon. Click on that and give me a second to go. Pulled out the results, and that was what gave me the number that I wanted. Okay.
Yeah, awesome. That's definitely a good way to debug when working on portals. Thank you.
Yep, you're welcome. All right, well, thank you so much, everybody, for coming. I will go ahead and stop the recording and look forward to seeing all of you at the next session.